Hey guys, David here and welcome to another Dark Art Workshop video. We're back at the CNC and that's because it's part 2 of taking care of a whole bunch of little things. Now we got quite far along the list in the first part, but quick spoiler alert, we're still not going to actually finish this original list. But, well, in the meantime, a couple of new things have popped up as well. You can see a little bit of a preview here on the table. For one, I have acrylic here. I actually got this like a year ago, and that's just to remake the dust shoe. The magnets don't line up properly, and there's a whole bunch of other issues. It has just been barely working enough that I didn't feel the need to remake it yet, but it's definitely time. So that's material for that. Then connected to the dust shoe is actually this little device here. I already mostly put it together, but it still needs a bit of more work. This is just essentially a single axis stepper controller, and what this will do is control the stepper motors to move the dust shoe up and down. Before that was done by muscle, but I actually need that channel because I'm getting a fourth axis. So now this will take it over. So I can adjust the height of it, have it manually move up and down, and it can also move up and down based on a signal that the muscle sends, and in return it sends back to the muscle whether the dust shoe is up or down. To build this, I actually made a little PCB here thanks to this video sponsor PCBWay, and it was just a really quick, simple. There's an Arduino Nano on here that kind of does all the logic, and then I made a PCB as a kind of breakout board to connect the different switches, to connect the LCD and the encoder wheel here, as well as all the other sensor inputs and outputs. Speaking of PCBWay, they don't just make really high quality PCBs for a very affordable price. They also have a bunch of manufacturing services, for example, sheet metal. And while these parts might not actually look like sheet metal, they are little clamps to hold down workpieces on the table. They're made from 3mm stainless steel, just kind of laser cut out and then bent in one single spot. And this is a really good way to hold down material, and these were actually very cheap to make as well. I'll show those in action in a little bit, but this will make holding down kind of awkward wood pieces a lot easier that don't have like a flat bottom, so I could tape them down or vacuum hold them down. Instead, clamping these on the edge should be really nice. But then the majority is actually this piece here. This is a piece of HDPE, and it's just representative here. I have much more material, and what we will be doing is the ATC cover point here. Right now, as you can see here in the back, all the tools are just kind of open to the elements. And the issue with that is that if I'm machining a bunch of stuff here, dust and chips lands on the tools, and while there is a little bit of a blow off, not every dust gets blown off, and a lot of it still stays in there, gets up into the spindle, into the mechanism that holds the tools, and that's just a bad day, and well, means that I have to get the spindle serviced all the time in order to get it cleaned out again. The only real way to solve this is to just enclose the whole thing and have it a little cover that automatically opens when the machine drives back to retrieve a tool. I've drawn up a design that I think is quite clever in CAD, but well, reality will tell whether it actually works or not. So with that, I think there's no time to waste. Let's get started. Alrighty, so we've made a bit of progress on the new dust tube. Now, I didn't really film much of me installing the brush, and that's because it was quite the royal pain. I didn't make the groove quite wide enough to use this like flexible one, which I used here. Now, we did want to use this one anyhow, because it's a bit shorter. This like fabric one you can only get in 2 lengths, and this is already the shorter one. So on this one I actually cut the bristles shorter, but that was also really annoying because they're quite hard. So I wanted to use this one. The issue with this one is that it has like a solid steel backer, and getting it properly bent without kind of the bristles going at an angle was quite difficult. It required a lot of persuasion, but I managed to get it in the end, and it's not perfect. Like these ones are pointing a bit in here, and the corners are pointing out a bit, but I think it'll be good enough. And you can see the magnets, they hold quite well. Now they don't hold super hard. If I notice it's a problem, I have some holes for pins, and like with this kind of situation, it's always much easier to pull away this way than to pull away down. So by having the pins in here, it'll add a lot of rigidity because you cannot pull away this way anymore. You can only pull it away down. I also finished up the 3D printing of the new kind of mounting. Now it's actually exactly the same as the old one, except I broke the old one, so needed to make a new one anyhow. Don't mind the really ugly stringiness of the 3D print. I think it's some old filament, but it should work nonetheless. Well, with the dust shoe all done and dusted, it's time to mount the new control unit for it, because I'm getting rid of the controls here on the Masso controller, and instead using this one here, so I can use the Masso A-axis for my 4th axis. I think I'm gonna mount this controller here next to the laser controller. There's space here, and behind it, it's relatively empty. I can move this power supply a bit. There's plenty of room to have this kind of stick in here. Now I'm gonna have to angle grind this hole out, and well, I don't wanna have metal shavings all over my control cabinet, so I'll have to pull up a board or something behind it and somehow try to contain the mess. Alright, so the easy part is done. It is mounted in here nice and solid. Next step will be to wire it up and finish programming it. But once I start doing that, like disconnect the old ways, I can't use the dust shoe for a while until it's done. And I don't really feel like doing that right now, so I'm going to procrastinate. Focus on other things by fixing this mess down here. Now, there's nothing inherently wrong with the pneumatics down here. They all work. It's just a giant mess. So I'm gonna try and clean it up a bit. And I also got a slightly larger filter regulator that I'm gonna replace one of the smaller ones with. And hopefully that kind of Gonna make it a bit less of a jumbled mess and a bit more reliable for the future. So here on the left we have the main air coming in, and then here we have a first kind of filter regulator. I'm mainly using this as a moisture trap. Then here I have a pressure sensor that goes to the muzzle to make sure that there's actually air pressure and it doesn't run the ATC without it. And it is also split before coming in here and going over here to this solenoid, which is the air for like the air blast on the spindle. And then after here, it goes into this solenoid, and at the same time it is split again with another Y fitting here, going in through this flow regulator into this solenoid, and this is for the laser air assist. And then that goes out here, and it's just the other thing is terminated with a shut-off valve because I didn't have a plug here. But the main part is going into this solenoid, which is the one that controls the ATC. And then out of here, there is another Y fitting. Part of it goes through this flow regulator to make, like pressure regulator, to make sure that the kind of spindle cone blast has the maximum of 1 bar. And the other thing goes directly to the locking feature of it. And that kind of takes care of everything. But there's like a Y fitting, another Y fitting, another Y fitting, and yeah, it's just a bit of a mess. Alrighty, well, it's still not the most clean install, but it's definitely a bit better. So I mounted a new regulator here, so it's coming in just here. So this then feeds this manifold here with 1 input and 4 outputs, 3 for the 3 solenoids and 1 for the air pressure sensor. And then from here it goes out. And I almost managed to clean install until, well, the tube from the air blast used to end here. Now it needs to go here, but I did not have that extra length anymore, so I had to improvise a coupler since I don't have any 8mm to 8mm couplers on hand. So I'll order that, and then there's like shut-off valve thingamabob here that is going to be gone as well. But I think with that now, all of the solenoids are like in one row, bolted down securely. This looks a lot cleaner. I have a lot fewer runs. Still a bit messy, but without like a proper like pneumatics manifolds that connects directly, it's going to be hard to get much better. So with that, we can cross off this point as well. So here I can see these new clamps that I had PCBWay made from stainless steel in action. Now this is kind of the inverted application, where like this side here I screwed flat down to the table, and then this side I like put up at an angle and then tightened it down to both clamp downwards as well as push it this direction. And the teeth make sure that there's absolutely zero way this is coming out. Now you can of course also like have them flipped over, but then you need like some sort of ledge that they can kind of push on, or if you're holding down flatter material from the top, that would work great. But for the side, this kind of slanted inverted one, make sure that it is nice and tight, and this is going absolutely nowhere. Now I've made sure to use some shims on the side so that it is sitting flat and I'm not putting any sort of twist into it when I tighten it down to the table. So now I can take off the top rough surface, and then I can use my regular work holding again once I have a flat surface established. So then I'll use just some masking tape and super glue for now when I flip it over, and later when I have my vacuum table built, then I can use the vacuum table for the next step. So since I don't know exactly how much you need to take off, I'm just going to do this essentially in manual mode, jogging over with a big flattening bit to get it flat down. Yeah, so this worked a treat, and putting them all next to each other, they didn't deform or anything either. Now I didn't think that like 3mm stainless steel, that's very tough. Like you might bend it slightly, but it's always gonna snap back unless you like way over tighten something. So this should be quite the useful addition. And I'll have the files linked down below. Not sure if I can do like projects for sheet metal as well on PCBWay. I know I can do it for PCBs. If I can, I will have a project directly on their website, so you can order those as well if you would like them for your CNC. The next item on the agenda is making the cover for the ATC. That is to keep out the dust from all of the tools here while I'm cutting. Now there is like an air blast coming over the tool before it grabs it, but if there's too much dust or if it's sticking a bit, then this doesn't always get rid of it, which means that there's dust either on the taper or gets up into the mechanics of the spindle, which is bad. So we're building a cover, and now the challenging bit of it is that it needs to be covered while we're machining, but then it needs to automatically uncover to change out the tools, of course. So I'm machining the first prototype here from HDPE. Now a Ctrl or a palm would be another great choice, but it is quite a bit more expensive. For these parts that aren't very structural, I'm using HDPE. It's a lot softer than palm, but looks similar, and it machines fairly well. You just need to make sure that you're taking a proper cut and not rubbing, otherwise you'll melt it. So here I'm calling this part the wall. It just kind of attaches to the profile here at the bottom, and it keeps chips from going in. This works quite well. It's designed so that the height is just below the dust shoe when it is moved up. And then here on the side we have these two kind of guide rail pieces, and up here will be a sheet metal cover. And as you can see, it already works fairly well. I have to push it nicely in the middle, otherwise it'll go crooked. But I will have two pushing pins in the end activated by the gantry, so that should be fine. The only issue is that I have a curvature going down here to close it off, because it needs to go down a bit lower. But this is just too much of a curvature. I cannot. I thought the thin sheet metal would easily bend down, but it's just not working. Now I could get even thinner material than this, since I obviously still have to get the actual material, but it's just going to become too flexible if I go even thinner. So I just redesigned these pieces with like a much more gradual curve. So this should hopefully mean that I can get it pushed in. Also, I have the 3D printer running in the background to get kind of the pieces that will connect it to the gantry printed for a first test. That way we can see if it is actually working as intended before I go ahead and buy the final sheet metal and all of that stuff. Alright, the new pieces are cut. Let's see how it goes. Definitely still some resistance, but actually some resistance is good. Because I saw before that when it was back here and just loose, it was kind of vibrating its way back. So we'll have to see whether the mechanism and everything is strong enough, but I think this might work. Now, of course, also like this piece is not fully complete, so there's a bit less force. But having a bend here, in addition to like being needed to get down lower, is also going to stiffen up this fairly thin sheet metal quite a bit. Because if there's like a bend in it, it doesn't sink down nearly as much. Alright, so I have the first prototype set up here for the like attachment mechanism. So this magnet here and over there, and corresponding magnets in here. And let's see how well this is going to work. So moving it back is no problem, that's no surprise. Then when moving forward, it pulls it forward until a certain point when the force is too much, which in this case now actually is all the way. This looks very promising. I was testing it before with the magnets the other way around, and it could only pull it until about here, and then the friction was too much. Alright, that is very good. Now, my prototype failed, magnet ripped out, the screw didn't really hold, but I can glue that in, that's not an issue. But this is really good. And the beauty of this design is that if something gets caught in here, and like for some reason it can't close all the way, and nothing is going to crash, the magnets are just going to detach. And so, worst case, it will fail open. So like if, I don't know, something is stuck in here, it's crooked or whatever, it's just going to detach and nothing happens really. And like if this stays open, that's not really a big deal. On the other hand, if it's closed like this, it's not just the magnet force holding it, but it's actually pushing against it. So something more catastrophic would have to be failing, like, I don't know, something ripping off for it to not open. Because like it not opening, that would be a big deal. And that would mean they would crash the spindle into it and it would be a bad day. But like this, that should hopefully work. Now, of course, it's not going to be attached with tape in the end. I'll probably have it screwed from the bottom or something like that. But for a first prototype, this is quite promising. Alrighty, so I've replaced the back panel now with one that actually fits and screw it in the little attachments. And as you can see, it works quite well. I ended up going with a 0.8mm aluminum sheet. I also tried 0.5, but that was a bit too flimsy. I could have added like some supports along the way, but 0.8 also works, so that's what I'm going with. And well, the magnets here, they're screwed in from the bottom with countersunk screws. Now, of course, the aluminum is way too thin to actually countersink them in, but I made sure to have like a matching countersunk in the 3D print, and that way I can just deform the metal into it and have enough meat to bite into without the screws rubbing on the powder coat of this cover here. I've used it for a couple of parts already, and it seems to be very reliable. And it's kind of designed in a way where the only places where it could possibly catch, it's gonna fail open and not fail closed. That's very important. I had it added some felts on the back to, well, not have it rub as much on here, but those were catching in the back, so I took them off again. So if I push it back here by hand, it can be a bit hard because it goes off canter. But for example, like if this lip were hanging down too much and catching on here, it would just not close all the way. When it gets pushed back open, it would fix itself. And like back here, it doesn't ever like go past like this during homing, and that's the furthest it goes back, so it like doesn't fall out there either. It is scratching up here, this powder coat a bit, but hey, what you gonna do? Now it works quite well. It's not perfect, of course. Some dust will still get in, and also like if some dust is sitting on here and it violently opens because it moves back fairly fast, then some of that dust will land in here just because it falls off. But it's much better than without, and like I'm still gonna go ahead and clean this out fairly regularly, but it just means that I don't have to clean it out before every tool change in order to not suck up any dust into the mechanism. And with that all working, I think the only thing left for this video is to hook up the electronics here for the dust chew control. Now all of the wiring and the coding is done now. Now it turns out this was a lot more complicated than I thought. Well, it's simple in principle. Having it actually work properly and like be performant was a bit of a challenge. Now it's not perfect, but I think it's good enough for now, and in order to make it better I would have to fundamentally change how it works, so that's what we're stuck with for now. Now in the meantime, also my master controller behind me, all of a sudden the touchscreen stopped working, and it seems to be a USB port issue because plugging in the mouse or a keyboard also doesn't work. So I'm in contact with Masso to get that fixed, but that means I can't actually properly test it. Now everything's wired up, I can manually move it, but I cannot test whether the connection between the Masso is working or not. I can manually poke the wire at it to simulate the connection, but that worked. But I guess we'll test the full thing later, as I want to finally wrap this video up. It's been way too long already. So now once I turn on the power, the Arduino here also gets powered. There's a separate power supply inside. I thought I had 5 volts available as well, but I actually don't. I only have 24 volts and 12 volts. So it got a separate power supply. Once it turns on, the dust chew does its homing routine, and then it's available. And now that it's homed, I can use this rotary encoder here to set a position. I can just change it here easily and have the set position on the top, and then I can press the down button. That moves the dust chew to that set position. And while I'm down, I can also use the encoder to fine adjust it. This movement is a bit stuttery. And the reason for it is that an Arduino Nano is not all that performant actually. So having the stepper library constantly update as well as the encoder constantly pull is kind of too much. So the stepper movement is not as smooth if I'm in kind of a following mode where I constantly update the position it's supposed to go to. Maybe there's some clever coding that could be done to improve that, but it kind of works for now. And moving up and down, it just has like one command to go to the up or down position, so that is perfectly smooth. So I can adjust where I want my dust hood, and then I can have it go up and go back down. And when the muzzle sends a signal, no matter if it is up or down, it will always move up and then go back to where it was before. So if it is down, the muzzle sends the signal for dust shoe up, it moves up, and once that signal is released, it moves back down. If it was up already, then nothing happens, it stays up, and when the signal is released, it also stays up. So it doesn't all of a sudden go down. And there's also a signal going back to the muzzle that tells it when the dust shoe is up. And that is needed inside of the ATC logic as well to ensure that it doesn't try to tool change while the dust shoe is actually down. Now, in case you want to build something similar, I'll have all the stuff linked down below, probably in a PCBWay post. The code is GPT generated, it's fine, it's not perfect, it could probably be done better, but it kind of works. And well, if you want to use it, feel free, but be advised that it's not perfect. So you'll probably want to improve it a bit if you want to make use of it. Now, coming back to the list here, we have made quite a bit of progress. We have also finished the ATC cover, that's been working great. Now, I am still working on the Y-axis backlash. After a long time, I finally managed to get in contact with Leadshine. I got in contact with their engineer, but then between me, like talking to them on the weekend, they responding during the week. And now the master being down, I haven't had a chance to actually try the suggestions yet. It's been a very slow process. Part of it is their fault, part of it is my fault. But I am working on that. And then the next video is going to be about the new spoil board. I'll be ditching this MDF board and going with a nice POM board, and also implementing vacuum work holding. I have all of the stuff here since January actually. Just need to actually implement it and build it, and then you'll get the video. Once that is all done and I've tested it, I will also be releasing the updated 3D files for this machine. If you've already bought the previous 3D files, you will of course get the new ones free of charge. And well, if you have not bought them, you will be able to buy them then as well. With that, we are at the end of this video. I hope you guys enjoyed this one and it wasn't too overly long. So thank you guys for watching, and I'll see you next time.